Hi class, how are you today? That's amazing! The learning target for today is to be able to add, subtract, and multiply polynomials. You're a 3 if you can add, subtract, and multiply polynomials. You're a 2 if you can add and subtract polynomials. You're a 1 if you can add and subtract polynomials, but only with 2 terms. There's only 2 terms there, not more than that. And you're at a 0 if you can add and subtract polynomials with only 2 terms. Let's get started. Polynomial is a mathematical expression of one or more algebraic terms. So here are some examples. Let's say we have x squared plus 5x plus 3. So this is an example of a polynomial. And what it means by terms is each thing between the addition signs is a term. So here, x squared is a term, 5x is a term, and 3 is a term. So everything separated by addition signs or subtraction signs are considered terms. So in this case, we have a polynomial with 3 terms in it. We'll get into talking more about what kinds of polynomials are, but today is more of adding and subtracting them. But here are a few more examples of polynomials. We can have 5x squared y minus 3xy squared. Those are polynomials, and this is one term, and this is one term. Again, the subtraction sign is what makes them different, is what separates them. So, one more. Let's say we have 9xyz. That's a polynomial. There's only one term in it, but it's a polynomial nonetheless. It's what's known as a monomial, but we'll get to that later. So polynomials are just adding different terms together. So let's start and actually do some math. So whenever you're adding or subtracting polynomials, you have to do what's called combining like terms. So let's start off with an example. Say we have 5x plus 3 minus 2x plus 7. And we want to simplify this. So what you do is you have to find the terms that are alike. These are the terms with the same exact variables. So notice we have 5x here. We have to find something else with an x in it, the same exact variable. Here we have minus 2x. Those two things are alike. And also, the numbers without an x are also alike. So here we have a 3, and here we have a 7. Those are alike. So we combine the like terms, or add and subtract the like terms. So we have 5x minus 2x will give us 3x, and 3 plus 7 will give us 10. And it's a positive 10, so we'll say plus 10. And we're done, because this is an x and this is a number. They can't combine because they are not like terms. So that's our answer. Seems simple enough? Awesome, let's keep going. Alright, so now, again, we need to find out which terms are alike. And remember I said they have to be exactly the same. So let's look at the first term. Here we have 2x squared, and we need to find what is also exactly the same variable. So notice that there is a difference between x squared and just x. They are different variables. Even though they both have an x, they are different because this is an x squared and this is just an x. So you cannot combine those two. By the way, little hint, make sure to write down the stuff I'm saying, not just the stuff I'm writing. So anyway, we need to find another x squared. Well, we have one over here, minus 9x squared. So we can combine those two. And then we have to look for other like terms. So here we have a minus 3x and a plus 4x. So then we combine the terms that are alike. So 2x squared minus 9x squared will give us a negative 7x squared. And then negative 3x plus 4x will give us a positive 1x, or just x. Any questions? If you do, make sure to write them down and tell me when we get to class, or even send me an email if you're really confused right now. I'll take them. Now let's look at this big problem. So here we have 12x squared. Let's look at what things are alike with it. So we need to look for another x squared. It has to be exactly x squared and nothing else. Well, I actually see two of them. Here we have a minus 9x squared, and here we have just an x squared. So those are three terms that are alike. Then let's look at y. So we have 4y here, and then we have to find something else with just a y in it. This right here has a y, but it's a y squared, so that's different. So this is a 4, just a 4, no y, so we can't combine anything else here. So 4y just stays 4y. Then we have minus 8y squared. Again, it's just a y squared, can't combine with anything else because there are no other just y squareds here. So then we have a plus 4. That's the only thing we have left. There are no other just numbers, so that just stays there. So then we add what we need to. So we have 12x squared minus 9x squared plus x squared. Just so we know, what number do we say is in front of x squared when there's nothing there? It's a 1. So that's actually a 1x squared. So now we're saying 12x squared minus 9x squared plus 1x squared. So 12 minus 9 is 3, plus 1 is 4. So that'll give us 4x squared. And then all the other numbers are all by themselves. So we leave them by themselves and just throw them out there. So plus 4y minus 8y squared plus 4. Nothing else can combine, they're all different, so that is our final answer. Alright, let's do one more. Alright, here's our last problem. So, let's look at the first one. We've got 14x squared y. So, we need to find something with the exact same variables. So that means it has to be exactly x squared y. Nothing different, has to be x squared y. We can change the order and have y x squared, but the square has to go with the x, and the y has to have no exponent at all. So let's go across. This has an x, but no squared. The squared is to the y. So that's different than this. This one has an x squared, and it has a y by itself. So x squared y, x squared y. Those are the same. And finally, this one just has an x squared. It doesn't have a y with it, so it is different. So then we get the other like terms. We have minus 18xy squared. Nothing goes with that. And 6x squared. Nothing goes with that. So we combine our like terms. 14 plus 2 will give us 16. X squared y. And then everything else drops down because there's nothing adding to them. So minus 18xy squared plus 6x squared. And it doesn't look very nice, but that is our final answer. So here we have the monomial, and here's the polynomial. So it's just using the distributive property. Multiply everything here by everything in here. So, first step, multiply negative 5x squared y times 3x squared. So we have negative 15, because negative 5 times 3 is negative 15. Then add the exponents. So x to the 2 plus 2, which is 4. And then there's a y here, but no y here. So the original y just stays there. Then we take this and multiply it by 9y. So negative 5 times 9 will give us a negative 45. And then x squared here, but no x's here, so the x squared stays there. Then y times y, so to the first, 1 plus 1 is 2, so y squared. Then negative 5x squared y times negative 8 x to the 4th, y to the 5th. So remember that negative times a negative will give us a positive. Then 5 times, then x squared times x to the 4th, 2 plus 4 is 6. So x to the 6th. And then y times y to the 5th, so 1 plus 5 is also y to the 6th. And then remember, this is x to the 4th y, this is x squared y squared, this is x to the 6th y to the 6th. They are all completely different, so they are all separate. You cannot add any of these. So this is just your answer. Alright, now for the next step in the scale. A binomial, 2 terms, times a binomial, 2 terms. So, it's the same principle. You're using the distributive property, except you need to multiply everything in here by everything in here. So, let's start with 2x. So we want to multiply 2x by the first term in the second binomial, x. So first term times the first term. So 2x times x will give us 2x squared. remember, add the exponents. X times x is x squared because 1 plus 1 is 2. Okay? Then we take the first term again and multiply by the second term. So 2x times negative 3 will give us a negative 6x. Then 2x, we've done everything with the 2x, so now we want to multiply the last term by each of these. So 5 times x, which will give us a positive 5x. And then second term times the second term. 5 times negative 3 is a negative 15. Now you can look at these and say, are there any like terms to combine? Well, x here, x here. Remember, they have to be exactly the same. So this is an x squared, not the same as an x. This has no variable, so it's not the same as anything with a variable. Okay? So these two can combine. So we've got the 2x squared can't combine with anything, so that drops down. And then negative 6x plus 5x. And then the minus 15 doesn't combine with anything, so it drops down. Can't combine anything past that, so that is our answer. Alright, now for the last example. We have x squared minus 4x plus 9. This is known as a trinomial, because there's 3 terms, times 3x minus 2, a binomial. So what you need to do is multiply everything here times everything in here. So, start with first times the first, x squared times 3x. X squared times 3x will give us 3x to the third. Then, x squared, the first term, times negative 2, the second term. So that will give us negative 2x squared. Then we have the second term, 4x, negative 4x, times a positive 3x. Negative 4x times 3x will give us a negative 12x squared. Negative 12x squared, because remember, x times x is x squared. Then, negative 4x times negative 2. So that will give us negative times a negative is a positive. 4 times 2 is 8x. Then we have the last term, 9, times the first term, 3x. 9 times 3 is 18. 27. 27. So a positive 27, and then x. And then 9 times negative 2, which is a negative 18. Then again, we look at what terms can we combine. Combine like terms. So, x cubed, not another one of those. So that stays 3x cubed. So then we have an x squared here and an x squared here. These two can combine. So negative 2x squared minus 12x squared. That'll give us negative 14x squared. Then 8x plus 27x, 2 x's. Add them together, 8 plus 27 is 35. So 35x. Remember, when you add them, you do nothing to the exponents. So the variables stay exactly the way they were when you added them. Okay, and then the minus 18 here drops down. So, minus 18. All separate exponents, x cubed, x squared, x, and then nothing. So, can't combine anything else. Now time for the sponge activity. Got 6 problems here, and for all of them I want you to simplify. The first 3 are adding and subtracting polynomials. The last 3 are multiplying polynomials. Alright, that's it for this lesson. Once again, please make sure to take notes on the entire lesson. Take a picture of everything, submit it all to Google Classroom, and have a good night.